Okay, great. Let's go through the first table, shall we? Some of the entries are self-explanatory, others are too advanced for now. We will focus on the most important of them. First, we have the dependent variable, or in other words, the variable we are trying to predict. Obviously, it is the GPA. Especially in the beginning, it's good to double-check if you coded the regression properly through this cell. Next, we have the model, which is OLS, or ordinary least squares. The method is closely related, least squares. In this case, there is no difference, but later we will see discrepancies. So, what is the OLS? OLS, or the ordinary least squares, is the most common method to estimate the linear regression equation. Least squares stands for the minimum squares error, or SSE. You may recall that a lower error results in a better explanatory power of the regression model. So, this method aims to find the line, which minimizes the sum of the squared errors. All right, let's clarify things with this graph. We can find many lines that fit the data. The OLS determines the one with the smallest error. Graphically, it is the one closest to all points, simultaneously. The expression used to do this is this one. But how is this formula applied? Well, this is a minimization problem that uses calculus and linear algebra to determine the slope and intercept of the line. After you crunch the numbers, you'll find the intercept is b0 and the slope is b1. Knowing the coefficients, here you have it, your regression equation. We can try minimizing the squared sum of errors on paper, but with datasets comprising thousands of values, this is almost impossible. Nowadays, regression analysis is performed through software. Beginner statisticians prefer Excel, SPSS, SAS, and Stata for calculations. Data scientists, however, favor programming languages like R and Python, as they offer limitless capabilities and unmatched speed. And that's what we are aiming for here. Finally, we must note that there are other methods for determining the regression line. They are preferred in different contexts. Such examples are the generalized least squares, maximum likelihood estimation, Bayesian regression, the kernel regression, and the Gaussian process regression. However, the least squares method is simple, yet powerful enough for many, if not most linear problems. We will stick with it for now. Thanks for watching.